All right, good afternoon, everyone. My name is Nan. I'm the IT manager for the emerging technology. And I hope you have a fun Friday afternoon here. And I was here this morning, all those presentations blew me away. It's like, I need to go back to school. And here, that's why I invite Professor Lone from U of C. So what he's going to talk about us is that we call the YYCRobot project. I want to give you a little bit of ideas about, so a few years ago, a couple of years ago, I think Jan and we have sort of an idea that maybe the next generation of AI and how robots can be used in a city is something that we should explore. For example, it's probably robots, lawnmower, right? I think we already tried with our recreation parks. And also robots for, how about -40, we have robots just outside clearing our snows and everything. And also, like, how about robots basically helping us clean up C-train platforms and pick up the garbage, etc. Right? Some of these simple ideas, which make us think that from IT, we think maybe we should have a better understanding about how robot works. So the idea is that yes, we can spend probably some dollars and buy a robot, put it here, but how about we just do something, crack open the box, and build something made in Calgary. And that's where that robot's coming from, the idea is, let's try it from scratch. In order to do that, basically give us an understanding that how exactly a robot works. And it's more important that if the robot pretty soon that say, now on our streets, our parks, how the City of Calgary can securely manage those robots. What about cybersecurity? Do we have a management platform? How do we make sure they're not going everywhere? I was just playing with our robot here, and the students and researchers told me that they intentionally slow it down, crack it down to speed, because it could be like a racing car here, and it could hit into any of you, right? If it goes anything wrong. So that's basically tell a story that there are some security measurements that we really need to understand and really want to put in place. And now we learned a lot through this process with U of C, with the Henry's group. And we also want to share that Henry's group, I think there are 2 other researchers here. There are multiple PhDs behind these things, and it's still difficult to figure out some of the parts, right? It's really complicated, and there's lots of learnings going on, and we really enjoy those journeys. So I'll let Henry share the details and how the project, right?
Well, thank you.
Go ahead.
Can you hear me? Thank you. Thank you, Nan, for introduction. And thank you for City for giving us this chance to present our work on this YYCRobot project. So we were approached by the City IT group. They suggest, can we design a robot to be used in the City Hall as a receptionist? So that's project one. Yeah. So originally, I thought that we thought maybe we can buy one. A lot of time we just buy one, but City said they want to have one built by Calgary. Okay, so it's totally designed and built by Calgary people. And there are certain functions originally we want to have. Okay, so first is the robot's able to greet the visitor to the city and also ask about what's the nature to the visit to the City Hall. Okay, so they can tell the city employee about services requested by the visitor. Okay, so that means the robots should have capability for verbal communications, talk to people, respond to people questions. Okay, we're able to send messages to the visitor about some available service. Okay, you can tell them, okay, you can do that, different type of functions. Okay, what the robot, we're also able to lead the visitor to different locations. For example, some visitor may come to, I come here for certain meeting. Okay, the robot can, that's the way, can guide them to lead them to that locations. Okay, so also maybe they can give some safety instruction or directions around the facility if needed, okay, if people ask about that. And also if the requirement, the location, or any necessary safety gear, okay. So these are all the requirements originally suggested by City IT department to design such a robot, okay. But we went through a long process in this collaborations. So we put the information in this way. We start from the IT group, okay? So they want to develop more advanced technology. You can use the technology, combine robot, IoT. And then they also hope the robots should be fully autonomous. Can interact with human. But after that, okay, we also discuss with the corporate security group, then they have different expectations. They also want the robot can able to achieve. So the robot should be able to alert the staff, provide opportunities to gather evidence for incident reporting. Something happens, okay, the robot can go there, take a look, report to them. Potential to integrate with the control center, okay, because they show us they have a control center in the city. So the information can send to the control center, more like a defense application. This robot can go around more surveillance. And then the IT group also bring us to talk to the facility management group, okay? So the robot, they also have a different view of the requirement of the robot. The robot should be able to guide the visitor to appropriate destination within the municipal building, okay? So this is added by the facility manager. Finally, we also talk to the advisory committee on accessibility. So they are more concerned about how about people, they have difficulty, hard to hear, cannot, loss of sight, maybe some difficulty with speech, okay? So they also hope the robot have this capability, can communicate with people with different types of needs. So we combine all this requirement and start to build the robot, okay? So this is, the robot will be eventually. So the owner, of course, is City of Calgary, okay, in the IT group, also the corporate security, facility management. The people they will interact, or we call the customer, would be, of course, the citizens of Calgary, also the corporate security, the City Hall reception group. And they can also, this robot, okay, we also think can have influence the industry, like Platform Calgary, design focus group, Calgary economic development, and some local robot industry or academic. They may be interested in that. So this is some background about this project. Where do we come from? Okay, how do we come up with all this requirement to design such a robot? Yeah, is to have is to have a Calgary built robot, humanoid robot. Okay, so let's talk about the team. Okay, the people involved in this project. So, because this is done by Calgary people, right? So they found us, University of Calgary. So myself, I'm a professor at the university at the Department of Electrical and Software Engineering, okay? So the work would involve different people. Gayan was my PhD student. He graduated now, working in the local industry. He's the main developer, okay? He takes care of the mechanical parts, most of them. So he is here, okay? King is a PhD student, okay? So he's doing more on the AI part, okay? So his expertise is artificial intelligence. So we have Anil. He was a postdoc fellow, but he left. He went back to India as a professor now. So he also involved the speech processing, okay? And we also have Johannes. He was a visiting student from Germany, okay? So he helped us to design certain part of the robot. Now he went back to German and working on the local industry in German. So he is quite international, okay? But we think, the robot, because we said it's from Calgary, it's not only from University of Calgary. So after discussing with the city, we think, we should involve more students. Okay, so we find some high school students to participate as well. Okay, so this is another team. We call our high school team. Okay, so we find different high school, okay, to be more distributed. So we find a private high school, Web Academy, UNES. Okay, so because the project has been 2 years, so when they join, it's grade 11. Now they all graduate. So now she is at Johns Hopkins University doing biomolecular engineering. We have Mayuri. Okay, she was with charter school, not private. Now it's charter. It's Westmount Charter School. She also graduated, and now is a first-year computer engineer at Waterloo. And we have Aliyah. Okay, so she was with the public school, Western. Okay, now it's a first-year computer science at U of T. And Bernice used to be in Sir Winston Churchill Public School, and now it's at UBC in engineering. So we think we have more distributed, more diverse involvement to design such a we call YYCRobot. Okay, and of course, very important, we have the city team. Okay, so you can see a long list of city people we have been talking to. They all give their opinions, suggestions, help us to solve the problems. So we have the IT group, lots of them. We have Nan, okay. We also have Achik, Colin, Misa, Suzanne, Harpin, saying, but I think we miss James. James helped us to suggest somehow to print the body, okay? Yeah. So we have corporate security. We talked to Keith, Alex, surgeon, Vijay, facility management. We have Alvin, Denise, and then advisory committee of accessibility, Leanne and Reno. Unfortunately, I cannot find all the picture from the public domain, so I can only put their name there. Okay, so that doesn't mean they are less important, but just very hard to get the picture. Yeah. Oh, that's okay. So this is the team with 3 groups, a lot of different academic, university, high school. We try to find some elementary, but I think it's too difficult to work, to ask them to do, you know. Yeah, they may play with the robot. Yeah, hard to build, okay? Yep. Then let's look at the robot design. Okay, so basically in our robot design, we have 3 major components. Okay, first is the mechanical design. So that means the whole body. Okay, so the whole humanoid robot. Okay, from the head to the body. Okay, so we look at the mobile base. Okay, because after discussion, we think it's too much. The cost is too high to build robot with legs. Okay, so we just have a mobile base. The arms, so we hope the robot can shake hand to people, give some guidance using the hand, or those not doing heavy job, okay? And then the head, okay? And then of course, because this is robot, right, we should have some AI, artificial intelligence capability, okay? So we expect the robot can do object detection, find out where's the target, where's the obstacle you can avoid, 3D perception, because you have to move in the 3D environment, okay? Speech, because we mentioned the key function of this robot is to talking to visitor to the City Hall. Yeah, oh, sorry, I double play, okay? It's a mistake, okay? And then finally, right, we have to have a good body design. Make it humanoid, okay? It's a very important part, right? Whether the citizen like to talk to this robot is the appearance, okay? We don't want them to feel afraid of the robot. They will feel this is friendly, they like to talk to him. So we have been thinking about, should it be more cartoon style, very real human style? Yeah, we discussed a lot. The skin materials and then the color to have this final design, okay? So let's look at that one by one. Okay, so the mechanical design is also based on a lot of discussion with the city. So we come up, this is the acceptable freedom, flexibility, the robot we should have. So they expect the hand can move, 5 degrees of freedom, okay? So the hand can do something, shake hand, pointing to directions, okay? The head, they want to have eyes, so they found it's good to have the eyes on the head, okay? The eyes should be able to rotate a little bit, more like human. They thought that we will feel more comfortable to the visitor. The head's able to rotate a little bit, okay? And then instead of legs, we have a base, okay? Yeah, so this is kind of the mechanical design requirement, and then the robot function at the end. Okay, so first, we will design using computer-aided design. We'll design the base, the chassis. Okay, this is the base with the kind of the main body. Then we will put the arms and the head to the robot. So now we are designing the head. Okay, so that's the location for the eyes. But this is the design. And then after we do the design, then we will build it. Okay, so this is the built one for the chassis, and this is over there. Okay, so it can move. So Ryan, can you? Yeah. Let's take a look at the base. Yeah, so it's important. We have to make sure when we discuss with the city, right? We don't want the robot is too noisy. We don't want the people scared. It has to be very quiet, stable, smooth. So when we talk to people or guiding people to different locations in the municipal building, they feel comfortable. So this is a lot of criteria we have to make sure they run in this way. Yeah. Yeah. Okay, so you feel free to take a look after this. I think you can use it. I think then just put a coffee on the top, and they can bring the coffee to him. Yeah. Well, then we look at the, this is the mechanical design. The next part is the AI, okay? So this is something we put more research, more novel stuff, right? It is innovation, right? So we have to do some 3D perception, okay? We only have camera, so we need to use some AI to generate the 3D environment, okay? So this is generative AI. So we can create a 3D environment from camera, so the robot can smoothly navigate in that conditions. Yeah. The video is too long. I think we can just stop here. Oh. Well, as you mentioned, right now, besides you can move, we expect to be like human, right? So you can detect objects. Okay, so we already designed the robot. Okay, we have very reliable detector, already trained it, ready to put on the robot. So you can detect human, okay? We can also use it, go by to count how many humans. Yeah, if the city need that, they can also use to select, to find some missing person, as long as you can give them the picture of that person, okay? Yeah, the other function, not only human, the eyes can also find objects. So if some visitor, they say, oh, I forgot my cell phone, I lost my jacket, then you just tell them, then they can help us go around to search for different types of missing objects. And then you can send it back to the reception group office or security. Yeah, so this is one function we'd like to have in this robot. Okay, and the next part, right, except the eyes, except the motion, we also expect one importance, the AI need to talk to people. So the robot can communicate, continual communications to explain responses from context for each individual. So you need to be able to answer different types of questions. Not only one answer, maybe continuous, if that person keep asking, you need to keep responding, okay? It's quite difficult sometimes because they also talk about how many lots of people talking. Okay, so we also need to prepare to handle those situations. Okay, so the setup should be completely offline. Now, this is the requirement from City, because without maybe we can connect to the internet. But they don't want to have that. They said they want to be isolated. They don't want to connect to any central. They don't want to record any citizen voice for security purpose. So they want everything local in that robot. Okay, so that's causing quite a bit of work to get it done. Potential, they want to have multilingual support. Okay, if people have different language, they can also translate and explain that to that person. Okay, now so this part we have difficulty. When we first start, we're developing a speech recognition systems, but in the middle of that, then we have ChatGPT. Well, that makes things completely change. Okay, so all the thing we did before is not compatible with ChatGPT, so have to switch. We also have to switch to using the large language model, okay? But then the challenge is the large language model is pretty large, right? So it is usually run in the cloud, okay? But then we have to, because of the second requirement, we have to put it in the local computer. Everything is local computer. We have to train using our data. You have to train using some of the questions City would like to have. Yeah, and that part is almost done, is kind of done. Okay, so we have to select fine-tuning, filtering procedures to reduce any possible false information response. Okay, so we haven't put that on the robot yet, but we can only show some examples.
Are there any libraries close to City Hall?
Yeah, so we only display, so it's easier to see. So that's a little bit time because you have to display the text. The response is pretty quick, where you can see, yeah.
Oh, okay. How do I get there?
We haven't selected the voice. We need to ask City which voice they want to use to represent it. It's not our voice, so City select is a male, female, who.
So how many minutes away is this?
Yeah, so we only display. Now we can do that, but we need to find a voice to represent this is the YYC. Okay, yeah, so
you're saying if I cross the crosswalk, I can get to the library?
Yeah, so we just, a little bit slow because we display the text, okay? So this
Thank you. Bye.
Okay, so that shows the response. Well, the last part is the body design. So as you can see, this is designed by the high school team. Even the presentation, they look different. Okay, they are younger. Okay, so that's why they search for different types of robot. Okay, which one is more friendly? I think they more tend to be more cartoon style. Okay, so they look for different types already in the market, in the business. So I think that's what they start from. And then they start sketching based on the requirements city would like to see. More friendly, humanoid type, but not too human. So they have different sketch of different types of robots. Okay, and then this is the final sketch, the final design. Okay, may not be very clear. This is roughly with the condition. We want the height. Okay, so we also discuss about the height. We don't want them to look like a kid. People may not believe a kid. We don't want to be too tall. So this is the height we design. So we give the condition to the high school team, so they will build that. So they would think this should be more human-like build. They think should be cartoon-like face with simple design. We don't know why, but they said this is good to be more blocky, okay? Yeah, so I think maybe this younger group like to see that. Okay, so then they use the software, yep.
The high school students' designs that, because we don't want to make it look like human, like too scary.
Okay. Yeah, I see. Yeah, so then they use the computer software to draw the design. So that would be the robot looks like eventually. You will see in City Hall someday. Yeah, it would be like this. Okay, the base is like that. Okay, so this is the wheel, this is the body, that's the hand, and this is the face. Okay. And they have some suggestions, the team. They want to have, on the base, they would like to put a painting like that to highlight this belongs to Calgary. Well, because they're all born in Calgary, right? So they want to highlight aspects and buildings that make Calgary unique by incorporating a modern art form. Okay, so that with the, I think this is Calgary Tower. I don't know which one is. I think this is the Peace Bridge. I don't know, that may be the Rocky Mountain. Okay, I don't know what is that. Okay, but anyways, they thought this picture represent in the base to show this is from the YYC, from Calgary. And they also want to have a sticker design. They suggest on the helmet, they want to incorporate some hand-designed sticker to put on the hat to represent, this is our design, that totally designed by Calgary, led by City of Calgary object. So we haven't designed that, or we wait for the city, maybe let the city to choose what they want to put the sticker on the hat, on the helmet of the robot. So maybe flames, maybe some Alberta national flower, maple leaf from Canada. It's up to the city group to choose, then we will try to put it there. Okay, so that's cover the YYC robot projects. Thank you. Any questions?
Yeah. It's moving now because when we start, originally we programmed this robot for City Hall. So when it's powered up, they're actually trying to scan the environment. So you put a robot into a new environment, it's scared, it's shy, right? trying to find out what's the environment, where's the wayfinding. So now once it's scanned, it starts moving, right? So that's what it took a little bit more time. Again, this is all learning. I didn't know this until today. So
Thank you. Any questions?
How did the project come about? How did the city and the U of C connect on this?
We have some background. We have been doing quite a bit of robot projects. So I think city contact us.
this is through the Urban Lines. Is it? Oh, Urban Lines, sorry, I forgot.
Yeah, Urban
the
Lines.
UFC Urban Lines project, yeah. We've been doing lots of research project with U of C. And then when we have this robot idea, say, hey, how about we try this, right? So yeah, it started from a research project, and then basically say, maybe we should try also build something more than a paper or research paper. That's how it come up, right? Yeah. can see there are lots of learning, right? Like even today, and I think Gayan and King was going to demonstrate the voice pieces as well, but it's not working as we expected at this environment, right? So there are lots of tuning and lots of learning pieces too. It's not as easy as we thought that just buying, but
Well, because we need to make sure it's very safe, right? We don't want to hit any people, cause any accidents.
go ahead.
Just wanted to mention, I am from the Urban Alliance. I'm the Office of Prosperity Research at the University of Calgary.
Yeah.
And Urban Alliance has been in place since 2007. And the city and the university have worked on over 400 projects together. So this is just one example.
That's awesome. 400 projects. That's awesome. Yeah. And I was just always like amazed, like when Henry mentioned that. 2 years ago, I think when we started this, is like, yeah, we built model. I still remember, I think it's one of our students training the large language model or natural language model, but all of a sudden like LLM, ChatGPT, and then now this Meta open source large language model. It's like, oh, right? That's so funny that all these technology evolve so quickly. Yeah.
I think it's easy to see how this could transition from doing tours for the public, but by being to that assistant even in a place like this or at transit, right? If you took all the user manuals for all the equipment in this room or all the user manuals on a Detroit engine in a bus, and so I could be the mechanic working on the bus and say, oh, how do I change the oil in this engine, right? And Jarvis could pull that up and show me a video on her face and right? I think that'd be really neat to have that personal assistant that can retain all the information on how to run our speaker system, right? That
Well,
we
even
don't
look
have.
at, to your point, like Jason, look at, for example, I'm thinking in our community center, when people, new immigrants, people doesn't understand English, come in, could talk to this guy. Oh, by the way, we need a name for this robot, so more than welcome to come some names. So, and talk to this and get the translation going on, right? So.
I think CSNC would like to run a naming competition. That's right.
Yeah. Jan was comment that CSNC would like to run a naming competition, naming hackathon, right? That's now we
We'll both all the schools.
Yes,
Get
yes.
the elementary schools involved that way. Okay?
That's
Oh, for sure.
Yeah.
Thank you so much for your presentation. I'm Vanessa from Bow Valley College Applied Research. My question is actually just talking about, this is a kind of first test use case if you're thinking about rolling out this out wider. How much does a robot like this cost?
Oh,
Kind of the background side of it.
It's, we try to make it very low cost because it's government money. We don't want to waste it. Yeah, so, but the manpower to develop it takes lots of energy. Okay, but after we have all the design to replicate, of course, will be way cheaper than.
Yeah.
Cheaper than the Pepper robot. I talked to Bow Valley, right? They are trying to purchase a Pepper robot, right? I think. Yeah.
Yeah. And we have been review lots of these procurement costs and keep mindful of that. Basically, so this robots, if just from the hardware perspective, it's really, really low cost. But as Henry pointed out, it's basically with these 3 or 4 PhDs, labors and times and efforts. But having said that, that's basically the one time you've done this, then basically it's a little bit, I wouldn't say cookie cutter, but it's much better and quicker to build the second and third one, right? It's like build army versus that build the first one. So, yeah.